So I'm going to call this part an interlude. We're in the middle of learning about statistical tests right now, and it's always good to stop and think about what tests have we learned and review what those tests do, what the hypotheses are, the assumptions, and also things to report. So I've gone through and I've created a document. This is a Word document, or in my case, LibreOffice document. A Word document is posted on Blackboard. You'll see it. It's underneath one of the lecture folders, or in one of the lecture sections. But these are the tests that we've encountered. One sample t-test, z-test, Shapiro-Wilks test, and the sign test. And this is what we've encountered up to this point. What we're going to do is start to fill this out. Why? It's because it's good to have some sort of cheat sheet or crib sheet available to when we are faced with that decision of what test do we run. This can help us. So we just finished with the t-test. What is this testing? Well, this test is testing is a sample mean equal to some value or to some population mean, mu. All right, so this is testing if a sample mean is equal to some value. What the null hypothesis is for t-test is always the average, bar x, is going to be equal to mu. Now we can go in and we can correct this. I can add an overline to this, so it's x bar. I can change this to actually the Greek letter mu, and I'll leave that up to you to do it yourself. If you want to do x bar in Word, you would type x, and then after x you would hold the Alt key and type 0773 and let go of the Alt key, and that will add an overline right to the x to make it an x bar. So again, you would type the x, and then so you would do x and then hold the Alt key and type in 0773 and then let go of the Alt key, and that will add a bar over that x. So our null hypothesis for any t-test is that our sample mean is equal to the population mean. Sample mean is equal to some value. All right. Our alternate is going to be that it's not equal to that some value. And for this, I'm going to insert a symbol. And in Word, it's a little bit different, but I'm inserting a special character, and we are going to do the not equals. So I can scroll down until I find the not equals. There it is. Insert that. So bar x equals mu, bar x is not equal, or we can do less than or greater than if we want a direction. All right, so our t-test, our null and alternate hypotheses, our assumptions, data are random and independent, and data are normally distributed. All right, and things to report, our conclusion, our test statistic, our DF, and our p-value. So t-test reports all of these. Now, as part of this, I'm also going to say what happens if we violate the assumptions. Well, if we violate normality, our options are to do a sign test or to do bootstrapped 95% confidence intervals. And this is our summary for the one sample t-test. We also have z-test, and we can do the same thing. Now I did add things to report, conclusion, test, and a p-value here. We've encountered the Shapiro-Wilks test, and we've encountered the sign test. So what I'd like you to do is create this document and try to fill this out. This will be good review. Good review so that you can go back to your notes and really think about what each test is testing, what the null and alternate hypotheses are, what the assumptions are, and also things to report. This is kind of important because It's going to be on your exam. It's going to be on the final. And I'll have questions where I give you the word problem and say what test should you run. So that's one option. And then also you'll see with our tests, we'll go through this and I'll ask you what's the null, what's the alternate hypothesis, what's your test statistic, what's your degrees of freedom, and so forth. So you have to report all that stuff. So right now you have this. Download the Word file and pause the video and then come back and let's talk about a couple of these tests. All right. So I know the sign test is up. So let's start with the sign test. What is this testing? It's testing, is the sample median equal to some value? That's what it's testing. Even though it's using the binomial test to test it, it's still, the sign test is still testing or answering the question, is the sample mean equal to some value? So our null hypothesis is the median is equal to some value. And our alternate, I'm going to highlight and copy that. Our alternate is that the median is not equal to some value. And we could do less than or greater than if we wanted to. Our assumptions, data are random and independent. And this will always be one of our assumptions. But we also have a requirement that our sample size is greater than 5. And the reason is it's tied to the binomial test. If we have a sample size of 5, we will never obtain a p-value that's less than 0.05. You can try it. Probability of getting 0 out of 5 heads is still greater than 5%. So if we assume 50-50 heads and tails and we get all heads or all tails, it's still, we don't have a large enough sample size to detect if our coin is not fair. So our sign test, data are random and independent, n is greater than 5. Things to report, conclusion, our test, and our p-value. We don't have a test statistic with this, and we don't have a degrees of freedom. All right, so I will leave the z-test and the Shapiro-Wilk test for you to do. We will return to this. This is part 1 of our interlude. We will return to this document and start adding additional tests as we encounter them. So the next couple ones will be, we'll add some equal variance tests as well as our 2-sample t-tests.